Welcome. On this video, we're going to be discussing how to properly divide polynomials using the synthetic division. So let's get started. Now, the synthetic division, you can think about it as a shortcut to divide polynomials, but there is one restriction, and that restriction is that we can only divide using binomials in the form x minus k. Some examples: x minus 5, x minus 2, x minus 20. So if we want to divide by some polynomials of the form x minus some constant, then only when we have that form we're allowed to use synthetic division. If we don't have this form, then we can use long division. But let's do some examples to demonstrate this technique. Now, in example A, we have the following. So here we have a division problem, and it states, let's perform synthetic division to divide fx by the given expression. Let's indicate what is the remainder, and let's state if the divisor is a factor. Now, here we have our problem. What we want to do here is we want to divide the expression 3x cubed minus 17x squared plus 15x minus 25, and we want to divide this by the expression of x minus 5. We can definitely use long division, and we would obtain the same result. But how can we properly use synthetic division? Well, first, let's talk about the setup. Well, the advantage of synthetic division is that under synthetic division, we really just care about the coefficients. So notice that we're going to just take a look at the coefficient of my polynomial on the top. 3 minus 17, 15, and minus 25. And what we're going to do first is realize if our numerator, it's in standard form. So everything is in order. So to the third, to the second, to the first, and to the second. So now what we're going to do now is we want to take those coefficients. So we're going to put a 3. Then we're going to leave some space. Then we're going to place down the next coefficient. Then the next coefficient. And then the next coefficient. So we're just going to align all those coefficients. And what we're going to do now is we're going to open up the box. But now notice that this box is different than the box from long division. Very much is the opposite direction. And now on the outside, we're going to be placing our value of k, where k is the constant, or at least the value that we're subtracting, which in this case is x minus 5. So 5 is the value of k. So therefore, I'm just going to place that 5 in here. And this is the setup. All we did, we took all the constants of my polynomial. I just aligned them. And then I'm just going to take the value of k, which in this case, k is 5. Our standard form is x minus k. So k, in this case, has a value of 5. And this is the setup. So now, what is the procedure? Well, the procedure is the following. The first value, we're always going to bring it down. In this case, it's 3. And what we're going to do here is now we're going to multiply. So we're going to multiply 3 times 5, which in this case is 15. We're going to write it here. And now that we have 15, we're just going to combine. Minus 17 plus 15, that's minus 2. And that's it. That is the procedure. We're going to repeat that procedure one more time. So now we're going to get negative 2 times 5. That's negative 10. And let's write down negative 10 on our next value. So we're going to write down negative 10 here. So after you multiply, you just combine. You don't have to switch the sign just like we did in long division. So now we combine. That's 5. And we're going to do it one more time. So 5 times 5, that's 25. So that's going to give us 25 here. We combine, and that's 0. Now, the last value that we get here, that is our remainder, which in this case, under this example, we have a remainder of 0. Now, if we have a remainder of 0, let's just write this down. Well, since we have a remainder of 0, then that means that x minus 5 is a factor. And what conclusions can we draw from here? Well, since x minus 5 is a factor, then we can say that the expression 3x to the cube minus 17x squared plus 15x minus 25, that is equivalent to x minus 5 times the result that we got from our synthetic division. But how can we interpret this result? Well, the values that we got here on the denominator or on the bottom, these are going to be the coefficients of a polynomial. But what is a polynomial? That will be a polynomial that is 1 degree less than what we started. So if we started with x to the third, then 3, this value of 3, is going to be the coefficient of x to the second. And then we're just going to continue. Negative 2 is the coefficient of x, and 5 is just a constant. And none of this is just faster. This is just some kind of a shortcut. And the reason why we call it a shortcut is because the procedure itself, it doesn't deal anything with variables. Notice that we didn't have any x's. We didn't have to think about combining like terms or switching signs and all that procedure that is needed whenever we do have long division. Under synthetic division, all we do is just work with numbers. We multiply, we combine. We multiply, we combine, and that's it. But now remember, what does the result mean? Like, what are the meaning of the values that we do have here? Well, those values are going to be the coefficient of a new expression. And what is that new expression? That is going to be 1 degree less than the polynomial that was on my numerator. So if the highest degree was 3, then this is a coefficient of 2. So let's assume that we have a different problem where my highest degree was 5, then therefore 3 must have been the coefficient of x to the fourth, and so on. So this is the procedure of long division, and these are just some general rules as to what can we do whenever we know that the remainder has a value of 0. Let's do another example. Here we have a different example, but now notice that here, under this example, it's a little bit different, because if we take a look at what is it that we want to divide by, that is x plus 3. But we said that synthetic division only works out when we have x minus a value, but here we have a plus. So are we allowed to use synthetic division? Yes, we can, but we just got to modify our expression a little bit. So how do we do that? Well, I want to take my numerator, but now the expression x plus 3, I'm going to write it as x minus 3. But now this way, I can assign the value of k to be negative 3. Because remember, we can only divide by expressions of x minus k, where k is the value that we have right out of the box, which in this case, if we made k equals negative 3, we have the original expression back. So now that we have that, let's actually set it up. Let's open up our box. The first thing I want to see is my numerator in standard form. To the third, to the second, to the first, a constant. So we're good. So all we're going to do, I'm just going to get all those coefficients. So I'm going to get a 5. And then I'm going to get the next one, which is 18. Then the next one, that is 7. And the next one, that is minus 6. And on the outside, I'm not going to write down plus 3. On the outside, I'm going to write down minus 3, because that will be my value of k. So now we have minus 3 on the outside. And now that we have our setup, now let's actually multiply. So again, this is always how we start. The first value, we always bring it down. In this case, we're going to bring down 5. And now we multiply. 5 times minus 3, but that's minus 15. And let's just write it underneath our next number. And now that we have that, we just combine, which in this case is going to be positive 3. And we're done with the procedure. Now we do it one more time. 3 times minus 3, that is equivalent to negative 9. And then we combine, well, that's equivalent to just negative 2. And we do it one more time. Negative 2 times negative 3, that is positive 6. So let's just write it out here. Positive 6. We combine, we get 0. And remember that the last value that we always get in our synthetic division, that is the remainder. So let's just indicate that. This is my remainder. We have a remainder of 0. And if the remainder is equivalent to 0, then that indicates that the expression x plus 3 is a factor. And since we know that x plus 3 is a factor, then we can just rewrite our original expression. Now we can say that 5x cubed plus 18x squared plus 7x minus 6, this is equivalent to x plus 3 times the value or times the expression that we got from our synthetic division, which is 5. But 5 is going to be the coefficient of what variable? Well, we started with x to the third. So now this is going to be the coefficient of x to the second. It's always going to be 1 less than. So this is 5x squared plus 3, and then you go 1 down, which is just x, minus 2, and then you go 1 down. Well, that's just a coefficient, a constant, not a coefficient. And that's it. So let's just box our result now. Let's take a look at another example. We'll notice that this example, it's a little bit different. So we know that we can still perform long division since we do have the expression x plus 2. So that's fine. Notice that we can rewrite this expression as just x minus negative 2. So that's fine. And this is going to be the value that we're going to be placing outside of the box. But what I want for you to notice is this. Notice that my numerator, the value x to the second, it's missing. So how are we going to set that up if we want to do long division? Well, there's one way to think about this problem. We can see that the expression 5x cubed plus 6x plus 8, this is equivalent to the expression 5x cubed plus 0x squared plus 6x plus 8. And it's beneficial for us to just rewrite it this form, because whenever we want to use either long division or synthetic division, we want to make sure that every single variable is being counted. So if you're missing an x to the second, what we can do, we can just assign it to have a coefficient of 0. Because 0 times x to the second, that's 0. And if you add 0, we just ignore it. And that's exactly what's just happening here. So this is the expression that we want to take a look, or the expression that we're going to be considering when we perform our long division or synthetic division. So let's get started. Let's get the coefficients, where the coefficient is going to be 5, followed by a 0, because 5 is the coefficient for x to the cube. Now we want to do the coefficient of x to the second, which is 0, then followed by a 6, then followed by an 8. We're going to close it. And now on the outside, we're going to do minus 2, because that is the value of k that we needed here. So now that we have it in this form, let's perform the actual procedure. Always bring the first one down. So that's a 5. And then multiply. 5 times minus 2, well, that's minus 10. 0 times minus 10, well, that's minus 10. And then we multiply. Negative 10 times negative 2, so that's 20. 20 plus 6, that's 26. 26 times negative 2, that's 52. And 52 plus 8, well, that's 60. But now notice that at least the procedure itself, we're done with it. But now we have a remainder of a value of 60. But since our remainder is not equivalent to 0, then we can say that the expression x plus 2 is not a factor. Because we can only conclude that an expression is a factor if our remainder is equivalent to 0, which in this case, we don't have it. But what I wanted for you to get out of this example is if there is a variable that is missing here, we can just assign a 0 to it, just like we did here. Now let's move on to our last example for today. And that is this example, which it might cause some confusion, because From the beginning of this lesson, we said we're only allowed to use synthetic division if we have expressions of this form, x minus some number. But if we take a look at the last example for today, we have a coefficient in front of x. So if there was no 3 in front of this x, if let's say if we would have this problem like this, then there would be no problem. We're going to just make k to be equivalent to -1, and then we can perform long division. But notice that we do still have that 3. We cannot just ignore it. So what do we do if we still want to divide or perform long division? Because you don't always have to do, synthetic division. You don't always have to do synthetic division. You can always do long division, but it's just too much work. So is there a way for it to perhaps rewrite the denominator in a way that it fits what it's needed for us to use synthetic division, x minus a coefficient? Well, let's see. Let's take a look at the denominator. So we got 3x plus 1. And let's just solve for x. Let's just solve for x. Minus 1. So 3x equals minus 1. And we said equals 3. So now we know that x is minus 3. So is there a different expression that we can come up with that will still give us a solution of x being equivalent to minus 3? Well, what if we let x plus 1/3? Like, what if we take this expression in consideration? Well, if we take this expression in consideration and if we solve for x, now we have that x equals minus 3. So notice that this expression, x plus 1/3, it gives us the same expression. It gives us the same conclusion as the expression 3x plus 1, which is the expression that we do have here in the denominator. So instead of looking at the denominator as 3x plus 1, I can just look at the denominator as x plus 1/3. And what's the benefit of that? Well, if we rewrite our expression in that way, so if we just rewrite our problem this way, minus 5x squared plus 4x plus 2 all over x plus 1/3. Now notice that my denominator, it fits the description, or it fits the requirements that are needed for us to use synthetic division. So sometimes if you do have a coefficient in front of x, try to rewrite a different expression that it still fits the criteria for synthetic division, and it still gives you the same solution as you originally have it. So we're not going to take a look at the problem as if it was written this form. Now we're just going to take a look at the problem as if it was written this form. And now that we have it in this form, let's actually perform long division. So let's get those coefficients. First, are they all in order? To the third, to the second, to the first, to the 0. So everything's in order. So let me get those coefficients. So we're going to get 3, followed by a minus 5, followed by a 4, followed by a 2. And now what's going to be my k? Well, my k here is just going to be minus 1/3. And now that we have it in this form, always bring down the first term, which in this case is 3, and let's multiply. 3 times negative 1/3, well, that's negative 1. And if we combine, that's negative 6. Negative 6 times negative 1/3, that's positive 2. Let's combine, well, that's 6. 6 times negative 1/3, so that's minus 2. Combine, that's 0. So now we can conclude that we have a remainder of 0, which is good. So that means that the expression 3x to the third minus 5x to the second plus 4x plus 2, that's equivalent to x plus 1/3 times the conclusion that we got from our synthetic division, which in this case 3 is going to be the coefficient of x to the second, since the highest exponent was to the third originally. So now we're going to get 3 to x to the second minus 6x plus 6. Or we could use the original. We could have said, well, 3x to the third minus 5x to the second plus 4x plus 2. Well, that's equivalent to 3x plus 1 times still 3x to the second minus 6x plus 6. So this is an or. We could use either or. And the reason why we can do that is because we just shown that these two expressions gives you the same result. So we could just use it either or. But we're still using our conclusion from synthetic division. So in this lesson, what we have covered is some basic examples for synthetic division, which will show you how to properly set it up. And also, we have seen some other examples where there is a coefficient that is missing, which in this case, notice that we can always assign a value of 0 to cover that coefficient that was missing. And we have also taken a look at a little bit more of a complex example where we do have coefficients in front of variables. So with this, it concludes our lesson of synthetic division.